Hey everybody, welcome back. Going to jump into some synthetic division, right? Okay, and again, we're gonna kind of continue things in. I'll do a couple examples here in. That's my beautiful. You see what look what I watch on YouTube, right? All kinds of Disney stuff, all kinds of nonsense. But anyways, back to this. Sorry. I've given you a little bit of an idea on, the initial stuff we talked about polynomials, right? So degree, terms, odd, even. We even jumped into, some types of roots, right? Like single, double, right? So singles are just going to pass right through the x-axis. Doubles are going to bounce. Take this thing off here real fast. The next thing we talked about, and this was on Friday. So if you weren't here on Friday, you're going to have to kind of explore this with us. Guys, we've taken great notes. Mr. Whiskey takes phenomenal notes in here. If you go into our chapter 8, okay, I think it's in reference, okay? So if you hit that polynomials reference doc, okay, you click on it, you go down here, his notes, you click on the notes right there, it'll take you to everything, we write down in class, okay? So again, I feel like I'm going to copy a lot of this, but it's still great to have it there. He does a great job of putting it in there for you. And again, we're going to kind of walk through some of these again today. Okay, so first one's going to be that x cubed plus 3x squared minus 10x. Okay, so number one, x cubed plus 3x squared. Make sure I got that right. Minus 10x, yep. Minus 10x. Okay, so again, we started off with this one. We said we would start off by possibly factoring this, right? Like this is one where we could take out an x to start, okay, and make this x squared plus 3x minus 10, and then we could factor it, right? We could take the x, and then we could break this down into x plus 5, x minus 2, right? So our roots would technically be, 0, negative 5, and positive 2, okay? So that's one option, okay? And if you feel great factoring, if you love just factor, then, go nuts, okay? However, if you wanted to, another alternative would just honestly just be start off by graphing it, right? We start off by plugging it in. Okay, let's jump over here to Desmos. Let's plug this bad boy in. So we're going to go x cubed plus 3x squared minus 10x. Okay, we'll turn that other one off. And again, we could just see this, that we have root at negative 5. That's going to be your x plus 5. We have a root at 0. That's going to be your x. And we have a root at positive 2. So right there, we've identified all three roots. And again, to take this negative 5, 0, and positive 2, it would not be very difficult for me just to take those values and write right here, right? Like that. Okay, 0, negative 5, positive 2, done. Okay, that's totally acceptable. Okay, so if you can plug it in and graph it and see all the roots, then just do it. Okay, I'm not gonna, we're not going to judge you on your factoring ability right now, okay? If we can plug it in our calculator and our calculator does the work for us, then so be it, okay? Now let's give you another one here. The other one we went through, again, jump back to his notes, the second one right here, okay? So x cubed minus 3x squared plus 4x minus 12, okay? So we go x cubed minus 3x squared plus 4x minus 12. Now, again, I should have mentioned this in our first example, but again, jumping back to the idea that, hey, this is a third degree polynomial, right? So how many roots do we need? 3. Same thing with this one. This was a third degree polynomial. How many roots do we need? 1, 2, 3. Okay, again, so keep those thoughts in your mind too. I mean, this is kind of a continuation off of the first video. Okay, so we still need 3 roots. When we graph this, okay, x cubed minus 3x squared plus 4x, I got that right. Minus 12, yeah, okay. When we graph this, so let's go x cubed, let me make sure I get that right. minus 3x plus 4. So let's go minus 3x squared plus 4x minus 12. There we go. Okay. That's what we see. Okay. So we know we need 3 roots, but what's the unfortunate part? We only see one of them right there at positive 3, right? So if there's only one root there, we have a situation kind of going back to the previous lesson, right? We have a situation that kind of looks like this, where we have 1 real root and 2 that are going to be imaginary or complex, right? So that's the situation we have. So we need to be able to take this equation and pull out, okay, pull out that single root at positive 3, okay? And this is where we talked about that synthetic division. So if you're around Friday, this should look familiar. If you weren't, that's okay. Just hang in there, and we'll spend this week kind of ironing this out, right? So positive 3 is our root, okay? So I'm going to put that up top. So again, make sure that's your x-intercept. That's the one you want to take. So then I'm going to list the coefficients of all of these. So in this case, this would be like a 1, negative 3, positive 4, negative 12, right? Okay, I'm going to list those coefficients. Now, again, you should be able to rewind this, so I'm going to kind of bounce through this just to save time. But if you have questions, go back and review it, or ask one of us in class, okay, please. So bring down the 1. 1's going to be there. We bring down the first one. 3 times 1 is going to give me a 3. Negative 3 and 3 are going to give me 0. I'm going to take the 3 times the 0. It's going to give me 0. Okay, 4, 0, give me 4. 3 times 4 is 12. That's going to give me a 0. Guys, if it's a root, we should end up with this 0 remainder right here. Okay, we should end up with that 0 remainder. And essentially what I did was I took out that 3, right? I took out this 3. And really I took out an x plus 3, right? And then I'm left with whatever's left over here. In this case, it's going to be whole numbers, x's, x squareds. Okay, and these are all positive, so we'll put pluses in between them. So what I have here is I have the initial x. I have the wait a second. That should be x minus 3. What am I doing? Because it's a positive 3 root, right? See, guys, be careful. I even make that mistake. Okay, so it should be x minus 3. So our final answer is going to be x minus 3, and then up top this becomes x squared plus 4. Okay, so this is my single root at positive 3, and this is my 2 imaginary roots, okay? And again, we'll talk about breaking this down. This becomes, again, positive 3. This actually comes down to plus 2i and minus 2i. So those are my 2 imaginary roots. We'll talk more about that later, but really I just want to focus in on the synthetic division right now. So the main goal of that, guys, is we have to get that single real root that we know at positive 3. We have to get that out of the way. We have to factor that out so that we're left with this piece, so we understand where our 2 imaginary roots are, okay? So again, we'll break that down a little bit more, but that's the goal of synthetic division, is to get those real roots out of there. What's the best way to find the real roots? Graph it, okay? Graph it. Let's jump back over here to the notes. We had one more that we did on Friday. Okay, it was this one right here. And again, I'm just going to walk through this one. So you see right away, guys, that we have a 4th degree polynomial, right? You see that up top, okay? So when we graph this, we saw that there's a double root at -1, okay? And again, let me jump up here. Let me jump to this. So 4, 2, 6, 10, 5. Okay, let's see if I can get this down. So let's go x to the 4th plus 2x cubed. Let me see if I got this right. I think I screwed it up already, but that's okay. Whatever. 2x cubed, 6x squared, 10x. Yep. Plus 6x squared plus 10x. What's the last part? Plus 5. I keep doing that. Plus 5. Okay. Sorry, y'all. It's late. Plus 5. Okay, so this is what we see. And again, get that purple one out of the way. And because this is a 4th degree polynomial, we know we need 4 roots. Well, unfortunately, we only see one x-intercept. And that one x-intercept happens to be a double root, which is great, right? That's great because that takes care of 2 of them. But then we know that 2 of them must be non-real, right? So again, our thought process is, hey, I need 4. I have a double, which takes care of 2. And by the way, imaginaries have to happen in pairs too. You can't have like 1 real and 3 imaginary roots. That's just not possible. Imaginaries have to have a partner. So again, in this case, we only have one x-intercept, but it's a double root that takes care of 2 of them. 2 of them must be imaginary. So what's our process? Not only do we have to take out -1 once, but we actually have to take it out twice, okay? And that's what he did right here in these notes, okay? When we graphed Desmos, we saw we had a double root -1. We just did that. So the double root, what it's going to look like right there is that x plus 1 squared, right? So we can do that. So we have to take out -1 twice, okay? So we took it out once here. You can kind of see, we took the coefficients, right? So again, 1, 2, 6, 10, 5. Again, 1, 2, 6, 10, 5. Bring down the first one, multiply down, add them together, multiply down, add them together, multiply down. Again, we should have a 0 remainder every single time, okay? If you weren't here on Friday, go ahead and copy these down because when we give you a couple examples in class, we're going to need you to do this synthetic division. And again, you should get a 0 remainder. If we know it's a root, we should get a 0 remainder every time, okay? So you see, once we took out this first -1, we ended up with this right here, this x cubed plus x squared plus 5x plus 5, okay? And again, that just became our next line once we decide we want to take out -1 again, right? We took it out once. We're going to take it out again. We're left with, you should end up with a 105. So that ends up being x squared plus 5. So then when we factor it all out, guys, this is our final answer. Now, you could write it as x plus 1, that's fine. Or x plus 1 squared, that's fine. But really that x squared plus 5, that represents the 2 imaginary roots that we, need to account for, okay? So again, all these, these are great notes. I'm going to make sure these get posted for both classes, and we're gonna dive hardcore into synthetic division this week. And I'm going to be in and out a couple days this week. I apologize, but like I said, please ask questions if you're unsure, and we're going to really kind of ramp this up. Thanks.